The cosmos beckons us. Billions of stars dot our galaxy. Around many of these stars, planets orbit. These are exoplanets, worlds beyond our solar system. They are shrouded in mystery, yet we yearn to know them. What secrets do they hold? What wonders await our discovery? For centuries, we could only imagine such places. Now, powerful telescopes allow us to peer across the vast cosmic ocean. Each new discovery fuels our imagination. We find gas giants larger than Jupiter, some scorching hot, others locked in a deep freeze. We find worlds that orbit their stars in mere hours, their surfaces blasted by intense radiation. But amidst this diversity, a particular type of exoplanet calls to us, rocky worlds like our own Earth. These planets offer the tantalizing possibility of familiar landscapes, of oceans and continents, perhaps even life itself. The search for another Earth, a twin of our own planet, is a testament to our enduring curiosity. It speaks to our desire to know that we are not alone in the vastness of space. Rocky exoplanets, also known as terrestrial planets, are worlds composed primarily of silicate rocks and metals. Unlike gas giants, which are mostly hydrogen and helium, rocky planets have solid surfaces. Think Earth, Mars, Venus, and Mercury. These are the planets where we might find mountains and valleys, rivers and lakes, and perhaps even the building blocks of life. Scientists are particularly interested in rocky exoplanets that orbit within their star's habitable zone. Also known as the Goldilocks zone, this region around a star is where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, just right. Why is liquid water so important? Because on Earth, wherever we find water, we find life. It's the lifeblood of our planet, and its presence on other worlds would be a strong indicator of potential habitability. But what if the water on these distant worlds isn't on the surface? What if it's hidden, deep beneath, locked away in the planet's molten core? This intriguing possibility has captivated the imagination of scientists, opening up new avenues in the search for life beyond Earth. Imagine a planet, seemingly dry and barren on its surface but harboring a secret deep within. Beneath the rocky mantle, in the heart of its molten core, lies a hidden ocean. Not an ocean of liquid water as we know it, but a vast reservoir of water molecules, locked away in the planet's very structure. This might sound like science fiction, but it's a real possibility being considered by scientists. The idea stems from the fact that even seemingly dry planets can contain water within their minerals. This water is not in liquid form, but rather chemically bound to the rock itself. As a planet forms, the intense heat and pressure can cause these water-bearing minerals to melt, releasing their trapped water. This water, denser than the surrounding molten rock, can sink towards the planet's core, accumulating over time to form a massive subterranean ocean. The existence of such a hidden ocean could have profound implications for our understanding of planetary formation and the potential for life beyond Earth. It suggests that water, a key ingredient for life as we know it, might be more common in the universe than we previously thought. Section 4. Probing the heart of exoplanets. Detecting water deep within the molten core of an exoplanet is no easy feat. The vast distances and extreme conditions make direct exploration nearly impossible with our current technology. It's not like we can simply send a probe to drill into these distant worlds. The challenges are immense, from the harsh environments to the sheer distance from Earth. Instead, scientists rely on ingenious methods and sophisticated tools to infer the presence of water from afar. These methods combine the latest advancements in technology with creative scientific thinking. One such method is known as transit spectroscopy. This technique has revolutionized our ability to study exoplanets. When an exoplanet passes in front of its star from our perspective, some of the star's light passes through the planet's atmosphere. This light carries with it valuable information about the atmospheric composition. By analyzing the spectrum of this light, scientists can identify the chemical fingerprints of different molecules in the planet's atmosphere, including water vapor. This process involves breaking down the light into its component colors and examining the resulting spectrum for specific absorption lines. Another method involves studying the planet's gravitational pull on its star. This technique, known as the radial velocity method, measures the tiny wobbles in the star's motion caused by the gravitational influence of the orbiting planet. The presence of a massive water reservoir in the planet's core would subtly alter its gravitational field, causing slight wobbles in the star's motion. These wobbles can reveal a lot about the planet's mass and internal structure. These wobbles can be detected by sensitive instruments on Earth, providing clues about the planet's internal structure. Advanced telescopes and spectrometers are crucial in capturing these minute changes. These methods, while powerful, are still limited by current technology. The instruments we have today are incredibly advanced, but they are not yet capable of providing a complete picture. Detecting water in the atmosphere or inferring its presence from gravitational wobbles are indirect methods. They require careful interpretation and often rely on multiple lines of evidence to build a convincing case. They can hint at the possibility of water, but they don't provide definitive proof. Future missions and technological advancements will be needed to confirm these findings and deepen our understanding of these distant worlds. Section 5. Glimmers of water. Whispers of life. While we haven't yet found definitive evidence of water in the molten cores of rocky exoplanets, there have been tantalizing hints. These hints come from various sources, including the analysis of light spectra and the study of planetary atmospheres. Scientists use advanced telescopes and instruments to detect the chemical signatures that might indicate the presence of water. Some studies have suggested that certain exoplanets, such as Kepler 186f and TRAPPIST-1e, might contain significant amounts of water, potentially more water than Earth has on its surface. These planets are located in the habitable zones of their respective stars where conditions might be just right for liquid water to exist. These findings, while still preliminary, fuel our imagination. They open up the possibility that these distant worlds could harbor environments suitable for life. The idea that water, a fundamental ingredient for life, might be abundant on other planets is both exciting and humbling. They suggest that water, a key ingredient for life as we know it, might be more common in the universe than we previously thought. This abundance of water could mean that the building blocks for life are more widespread than we ever imagined. And if water can exist in such abundance even in the most unexpected of places, then perhaps life in some form might also find a way to thrive. The presence of water increases the chances that life, even if it is microbial or vastly different from life on Earth, could exist elsewhere in the cosmos. However, it's important to note that the presence of water alone does not guarantee the existence of life. Other factors such as the planet's temperature, atmospheric composition, and geological activity play crucial roles in determining whether life can develop and sustain itself. Life as we know it requires a complex interplay of factors, including a stable environment, a source of energy, and the right chemical building blocks. These elements must come together in just the right way to create and support living organisms. The search for life beyond Earth is a journey into the unknown. It involves exploring distant planets, moons, and even asteroids, looking for signs of habitability and potential biosignatures. It's a journey driven by our innate curiosity, our desire to understand our place in the cosmos, and our hope that we are not alone. As we continue to explore the universe, each discovery brings us one step closer to answering the age-old question, are we alone in forward in our quest to find extraterrestrial life. The universe is full of wonders, waiting. All of humanity,